Let's explore SQL Self Joins. A self-join involves joining a table with itself to discover relationships within the data. So, what exactly is a self-join? In essence, it's a standard join operation where a table is joined with itself. This technique is particularly useful when a table contains what we call recursive relationships, meaning relationships between records within the same table. To properly execute a self-join, it's crucial to use table aliases. These aliases help distinguish between the different instances of the table involved in the join. Ultimately, self-joins enable us to uncover and analyze relationships between records in a single table, providing valuable insights into the data. When should we use self-joins? Firstly, for hierarchical relationships. It is used to find relationships within organizational structures, like employees and their managers in the same table. Secondly, for finding pairs. It helps to match records with other records in the same table, such as finding all possible pairs of products or customers. Thirdly, for comparing rows. It is used to identify duplicate records or compare records within the same table based on specific criteria. Lastly, for sequential data analysis. Self-join helps to compare data points with previous or subsequent entries, such as day-to-day temperature changes. Let's explore the basic syntax of a self-join. The code starts with a select statement. You select column 1 from table A and column 2 from table B from the table name using alias A. Then we perform a join on the same table, aliased as B. The on condition specifies how the two instances of the table relate to each other, where column name of alias is equal to column name of alias B. It is very important to use different aliases, such as A and B, to differentiate between the two instances of the same table. You can use inner join, left join, right join, or full join depending on the requirements. The on clause defines how the table relates to itself. This can be based on equality or any other logical condition. Let's consider a practical example using an employees table to illustrate the concept of self-joins. This employees table contains data about employees and their managers. Each employee has a manager ID that references another employee's ID, creating a hierarchical structure within the organization. As you can see, manager ID references employee ID in the same table, creating a hierarchical relationship. Let us try to understand employee-manager relationship with an example. The objective is to find each employee with their manager's name. Here is the SQL query to achieve this. We start by selecting the employee name and title as employee and employee title respectively, and the manager name and title as manager and manager title respectively. This is done from the employees table, aliased as the. Then we perform a left join with the employees table again, aliased as M, on the condition that the manager ID from the employees table matches the employee from the employees table. Here is the result table, which shows employee, employee title, manager, manager title. Let's explore another example to understand self-joins, where we find employees in the same department using a self-join. Here's the SQL query for this purpose. We select the name from the employees table, aliased as E1 as employee, and the name from the employees table, aliased as E2 as colleague, along with the department. We perform a join between the employees table aliased as E1 and the employees table aliased as E2, on the condition that the department from 1 matches the department from E2, and the employee from 1 is not equal to the employee from 2. Finally, we order the results by department and employee name. The result displays the employee, their colleague, and their department. Let's explore some best practices to keep in mind. Firstly, use descriptive aliases. Choose clear, meaningful aliases that reflect the role of each table instance in the query. For example, you can use the from employees table, aliased as employee, join employees aliased as manager. Secondly, avoid Cartesian products. Always include a proper join condition to avoid returning every possible combination of rows. Thirdly, consider performance. Self-joins can be resource-intensive, especially on large tables. Use appropriate indexes on join columns and consider query optimization. Lastly, choose the right join type. Select the appropriate join type based on your requirements. Inner join will only return matching records. Left join will return all records from the left table. Full join will return all records from both instances. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.